All right. In my case, when I look, watch what I'm looking. I'm looking at this. I'm like, oh, there is this line, there is this line, there is this line, there is this line, there is also this line. It's like there are 1, 2, 3, 4, 5 lines. Can you see that? So with those lines, they can ask me the distance of BE, the distance of AE, the distance of AC or GA or this whole GC, the distance of BC. That's distance. Or number 2, they can ask me to calculate the midpoint of BE, the midpoint of AE, the midpoint of AC or GA or GC, or the midpoint of BZ. You good? But next, they can ask me to calculate the gradient of BE, AE, AC, GE, or that. Or they might give me those things, then I will have to get the point. Next one. They can ask me to calculate. Now, let me do this. Let me just show you. Let me do this. This pink line, that is my x-axis. Can you see that? The lines which are cutting the x-axis is the red line, and then it is the yellow line, then it is the blue line. So that means if I'm looking at the blue line, pink to blue, that one, that is the angle of inclination. Pink to yellow is an inclination 45. You can see it of the yellow. Then pink to red, it's an inclination there. Then I still have another one here, which is green. Then I can say pink to green. It's also another inclination. Is it making sense to you now? Can you see that?
Yes.
Yeah. So they can ask me to find the gradient, to find the equation of all these lines. All right. Now, after that, then they can look at familiar shapes. Familiar shapes like a triangle. Maybe let's say this triangle here. They might say find the area of that. All right. Or here's another triangle here. They can ask me to find the area of that. Can you see that?
Yeah.
Or they can ask me to find the area of this whole picture here. You don't stress. All you have to do, break it into 2 pieces. Break it into that triangle and that other triangle. You work out the area of that triangle and that one. You add them together, correct? Or they can even look somewhere else. They can even come here and ask you to work out the area, maybe say of this one here. It's still triangle. Can you see that?
Yes.
They can still even ask you to work out that small baby triangle there. That's teeny little bitty one, that one there. Still a triangle. Can you see that?
Yeah.
Yeah. They can even still ask you to work out this one here, right here. It's a triangle, isn't it right? Yeah. The last one you were talking about exterior, there is that theta there. What makes that angle theta? It is the red line and the green line. There we go. So that means I just need to find that inclination. Once I find that one, I can find the interior where I'm shading. Then I can do the sum of the angles of a triangle, add up to 180. Then I can get that one. Is it making sense now?
Yeah.
Yeah. Can you see now? I just told you what they've got up their sleeve without telling me. All those things I said, they'll ask me to calculate. If they give it to me, if they give it to me, it means if they give me the equation, maybe I want to get when they give me an equation, that means the gradient is given. That means I can work out the point. All right, fine, let's forget. If they give me distance, same story. But let's read the question. They say quadrilateral AEBC, this whole big figure. Yeah.
Yeah.
Is drawn. Coordinates B is 3 and 4. There it is there. G, O, and F is 5 and 0. There it is over there. X intercepts. You see, they're telling me the X intercepts. So I know, yeah, Y is 0 there. By the 0 there, Y is 0 there. There where it's not labeled, Y is 0. By the G, Y is 0. So I'm going to quickly go by that one, because what I know, I normally insert it as soon as possible. I'll say, hey guys, come here. Here the Y value is 0. If I've got an equation, I can put 0 and get the answer. All right. Now they tell me A, C, B, C respectively. They say H is that line. There is H there. Now, is a point, it's just a point. They didn't tell me what it is. It's a point on line AC, angle, whatever it's theta, that one there. Area of, you see, look, they're giving me the area. I told you the rule. So they give me the area of OBF. OBF. Yes, O. Where is the B? And then here's the F. You see, they're giving me the area of this one. Can you see that?
Yeah. Yeah.
Remember, I said if you want the area of this one, you must know the two sides, which makes a known angle. You see that 45? So that means I can say area in this case equals to this side, OB. Side OB, remember I need to put half first, I'm sorry. It's half OB times the other side, which is OF, and then times by sine of the angle between them, 45. So check what you know. You know the area is 12. So that means I can put 12 here. So I don't know OB or OF. So they will ask me to calculate one of them. Can you see? Can you see BF? You can calculate by using distance formula, the BF. Can you see that?
Yes.
No, it's not part of it. I meant
You meant OB.
Yeah, no, but it's not by the origin as they did, unless it meant origin, but it's not. So we don't have that one. We don't have that one unless they give us extra information in the question. All right, let's go ahead and work out the whole thing. So I'm just going to underline that so that we don't forget. Check, what are they saying? They say an inclination line AB has 45. We're good. They say HC. Do you see HC? H is here. C.
Yeah.
It's twice AH. It's twice AH. So this one, if this part here, it's actually X, then this one here, it's double. It's 2X. Are we good? All right. That's what they say. It's twice there. Let's read the first question. Calculate the length. You see, that's distance. The length of what? BF. Leave your answer in a set form. Let's find B and an F. So where is B? Here is B. Here's F. So we want the distance for that one. I told this distance formula. You can call this one X1, Y1. You can call this one X2, and then Y2. Now we need X2, which is 5 minus 3. So in the brackets, it's 5 minus 3 all squared. Then you're working with the Y. Y2 is 0 minus 4. So it's going to be 0 minus 4 all squared. And then you take a square root. Can you see? It's chopped. So in my mind, I know 5 minus 3 is 2. 2 squared is 4. So under the square root, I've got 4 plus 0 minus 4 is minus 4. When I square it, is 16. So that will be 16, square root of that. So the answer is 2. Here it's 2 square root of 5. I've got the distance. That's the first answer. Do you see that? They say I must leave it in a set form. It's what I told you. They give you distance formula. So they ask me distance formula. But they don't have to ask me for the rest, because I could have done for the whole thing. All right, next one. Calculate the gradient. You see now they're talking about the gradient of BF now, what I taught you. All right,
Yeah.
so let's go to the gradient. So the gradient is changing y. Let's start by y2, 0 minus the 4. So you got 0 minus the 4. And then you're going to have 5 minus the 3. 5 minus the 3. At the top, I've got minus 4. At the bottom, I've got a 2. So I end up with minus 2. So now I can write, hey guys, the gradient of this line equals to minus 2. They could have asked me the gradient of the other one. Now, can you see, once you've got a gradient, I've got a gradient and points, I can find the equation of that line. But I can also find that angle of inclination here. Do you see that? Where I'm putting those ones. Yeah, I can do that one. All right, before they can even, I can get ahead of myself, but let's just go and let's just follow them step by step. They say calculate the size of angle theta. First, we check if theta is actually next to the x-axis. No, it's not. It's far away. It's exactly what I told you. It's formed by that red line there. And then it is also formed by the pink line, that one. And it is formed by the x-axis that I'm going to make it green. So you want that angle first here. Remember, it's a minus. Let's call that angle, maybe say, let's call it beta. Then I can say beta, it's actually arctangent of a negative 2. I told you when it's negative gradient, you add 180 because you can see beta will be obtuse angle. So shift tangent negative 2, you get that answer. There it is, plus 180 degrees. There we go. So you've got 116,57 degrees. That is this angle here. This angle is 116,57 degrees. Now, wait a minute. You know angle on a straight line. Don't you know angle on a straight line, my friend? You know it, am I right?
Yes, I do.
All right.
Yeah.
So that means I need to say 180 minus that 116. Actually, I didn't tell you. I know the answer. I'll tell you how I know the answer. Can you see it's 63,43? So you know here inside. It's now 63,43. Your teacher would have used that one on the outside exterior. Now you can do interior. Now let's go back here. Before you add 180 here, when you press shift tangent of negative 2, do you see the angle has a minus 2? A minus. It means start from the x-axis here, go down to the line. So it's telling you this line, this angle that I'm marking, the negative means clockwise. It's actually 63,43. But when you do vertically opposite angle, can you see it's equals to that one on the other side? Yeah, without making 180 minus. All right, nonetheless, we're good. So to find that theta, so all I have to do is to say 180. So theta equals to 180 minus, we're going inside the triangle, minus 45 minus 63,43. Is it making sense to you, everything that I'm doing?
Yes.
It's not sounding difficult, is it?
Not really.
They are asking you exactly the same thing I said they will ask you. Am I correct? All right, like what we did, I said distance, inclination, 71,57 degrees. There we go. Now you've got that angle there. So far, so good. So I can remove all this other stuff. Remember, it's gonna look like that. Now they say prove that HF is parallel. Wait a minute. What do you know about gradient 1 equals to gradient number 2? The two gradients are equal of the line if the lines are what?
A parallel.
That means for me to prove the lines are parallel, I must show them that the gradient are the same. We good?
Yeah. Yes.
Yeah, so this question is asking me, please go calculate gradient HF and also calculate gradient AB, but I didn't say direct. So I'm expecting them to be the same, HF, AB. Let's just see. Where is AB? Here's AB. AB is a red line, but I do not have a point here. How do we calculate gradient? Change in Y or tangent inclination? Am I correct? Inclination is 45. That means I'm going to type tangent on 45. I already know it's 1 this one. It's 1. So the gradient here is 1. Where is HF? HF. Okay, they say I must calculate HF. It was never shown. So I'm going to draw HF using blue. HF is from here to there. Can you see the blue line?
Yes.
So let's calculate the gradient. So the gradient of HF, you're expecting it to be the same. Y2, I'm going to start right at the top here. Y2 will be 0 minus minus. So it's 0 plus 4 divided by 5 minus 1. 5 minus 1. So at the top, I've got 4 over the 4. What answer am I getting? Is it 1?
Yes.
So what can you say about the red line and the blue line? They said we must prove a parallel. Good, yeah. Good. So if they are parallel, now I can tell them, I said, hey, that one is parallel to that one. It's parallel to that one there. There we go. Now, okay, I'm just adding, come on, you did parallel lines in grade 9, whatever, am I right? So when I do this, you know corresponding angle.
Yes.
So it means that angle, sorry about that, and that one are equal. Am I correct?
Yes.
Okay. Another
so 71.
Yes, 71, that. And also the other direction, like this way. That one and that one must be equal as well, isn't it? Yeah. So you're right. That angle, it must be 71, 57 degrees. Absolutely, absolutely right. All right. So now we proved to them. So in other words, I could have just said they're equal and both equals to 1. Then therefore HF is parallel to AB. They didn't ask you anything I never taught you. They're asking exactly the same thing. All right. Now they say it is further given that EC does what?
Bisect AB
perpendicularly. Bisect perpendicular is 2 words. This one tells me is what? I've got 90 degrees. Am I right?
Yes.
This one tells me I've got what? The midpoint. Can you see I gave even the keywords? There we go. They say what type of quadrilateral is AE? Okay, let's go find ECAB. All right, so EC, here's E, there is C. Okay, I think it will be like a kite, this thing here. I don't know, but it looks like
it's A, E, wait.
EC. Am I correct?
Wait, it starts with A, so it's...
There, EC must bisect AB.
Okay.
AB key, a rate. So that means that means EC, when I draw EC like that. Okay, when I want it to go at the right places, so it wants to rob me this thing. There we go. So when I write that, here it becomes 90 by the red line. And these two sides must be equal. Can you see? It's a kite, this thing. Remember you did a kite.
Yes.
Yeah. Right. Remember a kite, it must go like that, and then it comes something like that. That one equals to that. These two are equal. They are the longer ones. And when you draw a line and you got something like that, here it's here it must be 90, here and here it's equal. So here it means it's a perpendicular bisector. Come on, you see it, no? Yeah, it's a kite. So wait a minute before before I can go any further. So I know where let me put a black dot here. By the black dot, that is the midpoint. It's a midpoint of the red line.
Yes.
But the red line has a gradient of what? Of 1.
Yes.
That means I can find the gradient of a green because they are perpendicular. The 1 must be written upside down. It is still 1, and change the sign is going to be minus. So the gradient of the green is -1. Yeah. All right. All right. So yeah, they say if it is further given, they say what type? Oh, we answered it. It's a kite. Okay. They say hence from there, hence or otherwise calculate the length of AC. That is the distance.
Okay.
The distance of AC. Where is my AC? Yeah, from here
there.
to there. Here at the bottom. So I don't have to calculate AC direct. What do I mean? I mean that pink line is the same as the pink line at the bottom. Do you see that equal the pink lines? Yeah. If I get BC, I've got AB. I have a choice. Yeah, so the choice is mine. So let's try to investigate BC first, or maybe I can use theorem of Pythagoras. It will depend because here it's 90, everywhere it's 90. Here it's 90, it's 90, it's 90. So this triangle here is a right angle triangle. That one there is a right angle triangle. And then this one here is a right angle triangle. This one is a right angle. I just use descent from it. But I want to look at BC first. What's up first? So the question is, here's the question. The question is, remember that 2 root 5. It was for BF, I remember, I think, if I'm not mistaken. It was the first one. This it was BF. Can you see that? Good. Now, since this line here, the blue, is parallel to the red, that means also here it's 90s, isn't it right? Well, to convince you, I need maybe to do it this way and say, look at it this way. That line and that line like that. This is F, so that angle must be the same as that one. Can you see that? Corresponding, so it's 90. Good. So this tells me this side N must be equals to that one. Maybe I'm robbing you. You remember in grade 10 you did the midpoint formula? The midpoint, which tells you this side and that side, they are parallel. And then once it's finished, it told you something like this. This one is twice that one. Or this one, it was supposed to be equals to that. That one equals to that one in the sense. All right, but let me not go for that approach. But what I did so far, it was right. So let's see. So the question is, here I've got 90. 90 degrees here. And here I've got the angle there. Oh, okay. Oh, I thought it's gone. He's saying 10 minutes for us. It's 10 minutes, right? Yeah.
Okay.
This line, fed, it was, this part they told us it was twice that one. Now, the question is, can I get point C? Yes or no? Is it possible for me to determine point C? If I can get C, then I can work out that whole line, which gives me exactly what they want. Let me double check what is the thing. Yeah, they say hence calculate that. They're just giving you formats. Yeah.
Yes, you can calculate C.
All right. How are we gonna get C? What are you thinking?
I think you can use the midpoint formula for BC. I mean, for, the midpoint formula, right? Because you're given if.
Okay. But are these two equal? Have we concluded these two are equal? But I do know the angle is the same. That one. I'm thinking of another way. Because you're not 100% sure they're equal, these two, because they told you this one, yeah, it's twice that one there.
Okay.
So when I used to find either, if you find maybe say the x value or one of them, I know I can do it with geometry because it is geometry. That angle is the same as that angle there.
Yeah.
Point A. Do we know point A? I don't know point A. But yeah, I've got the equation of a straight line. I've got a straight line here. Gradient and a point. But I don't know any value of C here.
Yeah.
So I know how to do it, but there is a way I don't want to go after that because you didn't learn that one. It's called, it's actually a ratio. It's a ratio method. So if I do that, you'll be like, where did you get that one from? Okay, let me see if I can do it slightly different. Okay, let me check this one. Calculate the area of AOFC. Let's see. AOFC. Yeah, I don't know that. Okay, so there. All right, we need that point C. If we don't have point C, we can't, but I know a way of doing it. Yeah, but if I apply it, how we see it, well, we haven't done this. Actually, because I took from grade 12 here, I know it's a ratio method. I just say this side over the whole thing is that one over there. Okay, let me kind of show it to you exactly how it works. So what we do, I can take this whole side here because I'm calling it 3x. Can you see that? Let's call it 3x. So it's actually 3x. I must divide it by the whole side curve because that's why I must divide it by BC. Divided by BC. But remember, you know they are equal, the pink one for sure. You know they're exactly equal. Am I right?
Yeah. Okay.
Or you don't know that they're equal. They are equal, those two.
Yeah.
Yeah. It was straightforward in what I was saying. This one and this one, they are equal. Root 2 mona, root 2.5, limo root 2.5. It is the truth, that one. You cannot change that. All right. Yeah. Yes. Yeah. I remembered what you did here. Remember you did a trapezium SO. Isosceles trapezium. Do you remember isosceles trapezium? This one is parallel to that, and then here it's equals to that one. Do you remember? because you can do this one. So without finishing up there. All right, then it's clear now. Then that one is good. So that one, Eribitsang X, it's actually 2 root of 5. It's the same as that one. So this one, I must double this one, times this by 2, meaning it becomes 4 square root of 5. So now the whole length, I just add these 2, get it like 10, so to speak, it's 2, leave 5, get 6. So that means the whole thing, it's 6 square root of 5 units. That's what it is. So I don't even need that point Z to use distance formula. Okay, but when I just know this one will be equals to that one, and this little bit here will be equals to that one there, because they are parallel to one another. And those two sides the opposite. But then they are not, it's not bisecting that F. That means even if this blue line, let's say it was somewhere here. Let's say it was back here. That little portion there, red to blue, it was going to be equal.
Yeah.
Yeah, don't you know that parallel lines, why are they parallel? The distance between them must be what? The same.
Yes.
Yeah, so red to blue is the same. That's why. All right, so we're done with that part. Then the next one, they're asking me for the, I just want to copy this, put it as clean as possible so that you can see what they're looking for. All right, there we go. All right, so they say AOFC. AOFC, they want the area. So A, and then O, and then F, and then C. So I've got that. All right, one thing we know, this side is now 6 square root of 5 units. Now, do you see this figure? It does not look, it's not a triangle. Can you see that? It's not a triangle or right angle triangle. But one way to do something, you can do it this way. You can calculate the area of this whole triangle, like this one. This whole triangle. You see the orange one? And then you calculate the area of this blue one, Kahudim. Then you say the bigger one, the orange minus blue, it gives you what remains here. You remember you understand what I'm saying?
Yes.
All right. So how do you get this orange one? Well, the orange one is easy because this is what I'm going to do. We have this line, and we also know that red line there. Am I correct? Yeah, they are both root 6, 5. So it will be, I mean, it's 6 root 5, so to say, like that one. So that means these are the two sides. I just need the angle, this one here. Let's go back where we were to see if we could figure out that angle. Yes, we can figure out the angle, because if you pay attention on here, remember it's 90 there, and here it's 71.5. Am I right? So by the sum of the angle of a triangle, you can get that little bit, meaning you can get